This is our last lecture on the probability and engineering economy. Actually, we're going to have a review session for what we learned from all this for the part 3. So the review questions has been uploaded and you can check them out. We're going to go through a few of them. The so for part 3 we learned quite a few things, we discussed quite a few things, but really the core things we're going to we learned, all of those are related to present value, future value, and annuity, right? Basically just these three concepts. How do we convert from present value to future value? How do we convert from future value to present value? How we have those numbers and then find out annuity, so on and so forth. The basic concept is that money today worth more than money tomorrow. If you can have $1 today, don't let someone trick you and say, I'm going to give you tomorrow. No, money tomorrow will never be as good as money today, right? Now, if someone say, I give you money now, take it, right? Take it now. But I mean, if, someone says, well, okay, I owe you $1, but sorry, I cannot give you today. I have to give you tomorrow. You're going to say tomorrow $1 is not $1. Tomorrow $1 will be $1.01. So you need to give me that much, right? So future value must have certain interest on it to have the equal value to amount of the present value, right? To the amount of the present value. That's really just it, right? We have a value and we have interest rate, right? How we calculate, and all the calculations are based on this. And we did all the calculation for single cash flow. We calculated how to convert them. For uniform series, the annuities, we did all the calculation as well. And then in the middle, we also calculated about the linear gradient series. You can forget all these equations and then just all those equations are help you to calculate it a little bit easier, faster, right? Calculate present value or future value a little bit easier. You can always just say, okay, here's the cash at year 1, use interest, I'll convert it back to present. Here's another cash flow on year 2, I'm going to convert it, use interest to bring back. The concepts are exactly the same, right? If you do that calculation, you're going to get the exact number one by one calculating that. But the only thing all these matters is to make your calculation a little bit simpler, and that's it. Same thing for the linear gradient theory series, right? It's the same thing. You can use each one, use the interest to convert each cash flow to 0, to the present value, to year 0, and add them all together. It doesn't change anything, right? The only reason we have this function is to have this equation is to make our calculation a little bit easier. That's it. Another relatively important concept is the effective interest and nominal interest, right? Nominal interest is that, okay, the bank tell you the interest rate is 12%, but it's charged monthly. It's charged monthly, right? Then the nominal rate, nominal annual interest, need to divide it by m the payment period. Let's say it charged monthly for annual rate. Then you use that 12% divided by 12. Let's give you 1%, and then 1 plus 1%, then multiply by m. That number minus 1 give you the effective annual rate. And this value is always bigger than this value. This value is always bigger than this value. So that's what we learned, right? That's what we talk about. We're going to, like I said, we're going to review a few questions, and the answers are already provided, but we're going to talk a few of them here. All the short answers, you can find them from slides. I'm not going to talk about them here. Let's just go into the calculation ones and make sure you understand how to calculate those. Question 3 is this one, right? The nominal annual rate for a loan is 8% compounded monthly. What is the effective annual interest rate? And I already gave the number here, but this is the equation basically we're going to use, right? We have an annual one, but then compounded interest. So R here will be 8%, right? And M here is going to be monthly, so 12, right? And then use this equation, you should be able to calculate. So maybe try it and see if you get the right number or not. Or you can pause the video and take a few minutes. All right, I hope you get the number, but really, this is what we do, right? This is exactly what we do. We plug in the number. R is 8%, M is 12, M is 12 again, minus 1 give you the just interest rate, and this is it. This is what you're going to get, and it's 8.3%. And like we said, right, the effective interest rate should always be bigger than the nominal interest rate. If after you calculate, you find out, oh, actually my effective interest rate is smaller than the nominal interest rate, then there's something went wrong. So you need to double check, right? All right. Okay, so that's question 3. All right, question 4. So first one, I'm asking you if this is true or false, right? Is this function equal to this function? Is this function equal to this function? So this is basically what we do before, right? I'm giving you annuity, I'm giving you the interest rate, I know the n. For annuity, and it's happened in n period, I'm going to calculate p, right? This is the equation we used before, right? So this gives us present value. I'm asking if this equals to, we have annuity, right? We only take one of the annuity, I bring it back 1 year. I assume this annuity only happened once, right? And I bring it back 1 year, and then I multiply by n. I multiply by n. So I'm asking you if these two are the same or not. Take a moment, calculate this, or draw this, whatever helps, think about it. And you can pause the video and then come back. Okay, so this is false, right? And the reason is this. For this one, this function, this is the correct one. We use it many times, right? We have annuity, something like this. When we apply this function, we get this. We get this, right? We get this. And this one means I basically, I take 1 and I convert it back 1 year. I converted this back 1 year. And then I multiply by n times, right? I multiply by n times. So I can put here, 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 here. All these values are the same because this is all based on just this value. For 1 year's annuity, I bring it back 1 year, and then I do n times. I add them all together because I multiply by n, right? I can add them all here, and I assume they are the same. I assume they are the same. Of course, this is not correct because not all the annuity has been bring back to year 0, right? Because think about it. We basically did this, moved this here. We moved this here. We moved this here. We moved this here. We did bring everything 1 year back, but only this one has a present value. Only this part is a present value. All these 3 are still future values. We haven't bring them back yet. So we have to bring them one by one back, or convert them back to their values at year 0. Then these 2, the pure value of these 2 could be the same, right? So that's why this is false. If you still a bit confused, try to use add some number, give some number I or A, and calculate it. You're definitely going to find that they are not the same, right? Okay, so there's another question. A company received a loan for $100,000 by getting a 30-year mortgage with monthly payment. The APR rate, interest rate, is 6% per year, compounded monthly, and their monthly payment is less than $600. Is less than $600. Do you think this is true or false? Do you think this is true or false? So sounds like a true or false question, but probably need some calculation, right? So I give you some time and try to calculate that. Come back, we can try it. All right, so for this question, really what we need to pay, what we have is a present value, right? What we have is a present value. This present value is what we own, what the company owns, right? That's $100,000, and the company need to pay it in 30 years. But it actually needs to have a monthly payment, right? So the total payment, although it's over 30 years, but the total payment is actually 30 multiplied by 12. That's give us 360. And then the interest rate is not, the annual interest rate is 6%, but because it's compounded monthly, we need to use 6% divided by 12. So that's 0.5%. That's 0.5%, right? So basically we now, based on this, we have P, which is 100,000. We have N, which is 30 multiplied by 12. We need to make 360 payment. The interest rate is 6 divided by 12, which is 0.5%. Then we're basically just trying to calculate what is A, right? We're basically trying to calculate what is A. So now we have P, I, N. We need to calculate A. This is what we want to use, right? Put P here. I is 0.005. That's I. Same I here. N is 360. Same thing, we put all the numbers down here. And after the calculation, we get $599.55 and 55 cents. Right? That's the monthly payment. So it is true that it's lower than 600. Not by much, but it is lower than 600. But that's question 4. You want to pay attention to the compound interest, right? What's the number they gave you? What is the interest they gave you? Do they give you nominal interest rate or the compound interest rate, right? Or the effective interest rate? So definitely make sure make sure to distinguish those, see them clearly. Now here's question 5. The following cash flow estimates have been developed for 2 small mutually exclusive investment alternatives. Make a recommendation about the preferred alternative using the annual worth method and assuming the median attractive rate of return equals to 12% per year. So basically this table here shows the 2 differences, right? So they are mutually exclusive alternatives. For alternative 1, year 0, this means that at year 0, your investment is 2,500. Then each year you get 750 into year 5. Year 5 you got 2,750. Well, that's a big jump from previous years, right? For year 2, same amount of initial investment. Each year you get more money, but it stays the same even until year 5. Right? It's always $1,000. So the question is, based on this, how do you calculate which one is better? Which one is better? Okay, pause the video, take a few minutes, and calculate this. All right, I hope you already have the answer. Relatively straightforward, right? We just use whatever we learned before. So for alternative one, right? What we need to do is that we want to convert everything to annuity. We want to convert everything to annuity, right? We want to convert everything to annuity. Well, that's my approach. I'm using the annuity part, but you can obviously use any other approaches, right? So for here, first thing, this is my initial investment, right? Initial investment. I'm going to convert this to annuity, which is over 5-year period, and then the ARR, the interest rate, is 12%. So plug in, but if I have P, how do I calculate A? That's this function, right? This function. So I basically just use this, multiply by this with a period, and convert. That's how I convert the initial cost to annuity. Don't forget that this is out cash flow, so there is negative, right? Even though in this question I already showed that it's negative, but in some time maybe people will say this is initial investment or this is cost. Then you definitely want to make sure that you are make sure that's negative, right? Then another thing, so I have 750 here because in fact here is already an annuity, right? On year 1, year 2, year 3, year 4, we all have 750. Year 5, we have a little bit more, but we can take out the 750 just like all the other years and assume this is the annuity, so the equal part. Then for year 5, what's left is the other $2,000. That's our future value, right? This $2,000 in the future value, I need to convert that to annuity. So same thing with future value. How do I calculate the annuity? It's this function, right? I, we know, 0.12. N we know, which is 5. So I use this, put it here. After all the calculation, the number is $371.3. $371.3. That's alternative 1. Alternative 2, even easier, right? Because I already have annuity. Each year is already $1,000. I just need to convert the first year's investment to annuity as well. So I basically did this. I know P, I'm calculating A, then each year is $1,000. I add them all together, 306.3. Okay, that's question 5. Question 6, here it is. What is the present value of a cash flow that pays 100 at the end of year 1 and 200 at the end of year 2? The interest rate is 5% in year 1 and 7% in year 2. All right, give you a minute to calculate that. Now, this is what I was saying at the beginning, right? Sometimes, all these questions we have here, they cannot be applied directly to put all this number in and calculate one result, just because I actually changed, right? But if you understand the present and the future value perfectly without any issue, you know the fundamental concept, really what we need to do is just find each year's cash flow and convert that back to year 0. And that's what we are trying to do here, right? So for the first one, we have year 1, $100, right? Year 1, we have $100. The interest rate for this year is 5%, and there's only 1 year period, right? So we convert that back. The present value is 100. Do the calculation, basically divide by 1.05, and we get $95, right? So this is easy. This part is a little bit tricky because our cash flow, the second cash flow is on year 2. It's still a future value, $200, right? So we need to calculate that, convert that back. Now, because the 2-year interests are different, we need to convert back one by one. So first thing we're doing is using this future value, using the second year's interest rate, and we convert to one time. So this is basically 200 divided by 1.07, right? Divided by 1.07. Well, now we convert it, but it's still at the end of year 1, right? Because we only converted back 1 year. Now we need to convert it back again to year 0. For this year, now we're at the end of year 1, right? From end of year 1 to year 0, the interest rate was 0.05. And then the time period is still 1 year. So now whatever value we calculate here, we need to divide by 1 plus 0.05. Now after this calculation, the value is 178. So this is for the second cash flow. We added this two together, let's give us $273. That's the present value for all the 2 cash flows. So again, this is take some. You can imagine that this is only 2 cash flow, right? But you can imagine if we have 30 years and each year have different interest rate, that's going to take a while to calculate. But the concept, as long as you understand, it's just calculation, right? You can use computer, you can use Excel to calculate this. It's as long as the concepts are clear, we just need to do them step by step. That's question 6. Question 7, a company plans to purchase a new machine in 6 years at an expected cost in 6 years of $10,000. How much should the company invest now to afford the new machine in 6 years if the interest rate is 8%? If the interest rate is 8%. Now take a minute to calculate, then we can do it together. So what the company want to do is basically purchase a new machine in 6 years. Like you, right? Maybe like you guys, I want to buy a car in 6 months. I want to buy a house in 5 years. Now you should start saving. You should start saving money, right? And you save the money, and then whatever you save, you put into the saving account, you put into stock market, you put into index fund to see them grow. So in 5 years, you get all your money and all the interest you accrued, take them, and then pay for the down payment for your house or pay for your car. That's the same concept, right? So basically, the question is asking how much money the company need to save. How much money the company actually need to save to be able to afford that amount of money, to pay $10,000 to buy the machine, right? So, well, we know the future value, which is the cost of the machine, is $10,000. Meaning, obviously, in 6 years, you need to have $10,000 of cash to buy the $10,000 machine, right? So how can you get $10,000 of cash? Well, we know the period is 6. We know the interest rate is 8%. We just need to find out present. We have a future value. What is the equal present value? So we basically have, it's not this function, but basically we use the future value to calculate the present value. And that's what we did, right? So future value, interest rate, 6%. You can, if you want, you can go back a few slides and you find the equation and then calculate. It will give you $6,302. That's for question 7. Question 8. Question 8 is something like this. Two mutually exclusive alternatives are considered. The cash flows associated with each alternative are shown below. You can see for the two alternatives, initial investment, this much, annual cost, a bit different, annual revenue, a bit different. One useful time life is 4 years, the other much higher, 10 years. The salvage value at the end of useful life, this much, right? If the MARR is 15% and the repeatability assumption is valid, okay, repeatability assumption is valid, which alternative, if any, should be adopted? Choose the most appropriate method for your evaluation. Okay, take a few minutes to calculate. All right, so if repeatability assumptions are valid, and the reason this need to be valid is because the two projects actually have different years, right? Different durations, period of times. That's why we need to make sure the repeatability assumption is valid. If it's not, we cannot calculate anything, right? We cannot do the comparison. If the repeatability assumption is valid, two options we can calculate. One, we repeat, one alternative or both alternatives multiple times, make sure that, they start at the same time and end at the same time. Then we can calculate the present value, future value, and then do the comparison, right? So for this one, if we do want to do that, we first need to find the common multiple, right? We need to find the common multiple, because only if we find the common multiple, then the two projects can end at the same time, right? So for 4 and 10, the common multiple is 20. That means we're going to repeat project A 5 times and the project B 2 times, and then they both end at year 20. Now they have the same period, we can do the same calculation, so on and so forth. That's doable, but a bit complicated, right? We said before, especially for a 20-year cash flow, I doubt any of you want to calculate in that way, right? Really, the easiest way is to calculate the annual annuity, right? The annual worth. Now, so no matter how many times you repeat it, the annuity doesn't change. If the repeatability assumption is valid, the annuity doesn't change, we can compare them straightforward, right? So we calculate the annuity. For A, basically what we need to do is that we already have annuity here, right? Which is, we actually have two annuity here. One is annual revenue, which is 14,000, so 14,000 here. The other one is annual cost, which is 7,000. We put it here, it's negative, right? And we basically just need to convert this two to annuity. We have a present value, negative 22,000, it's investment. We have the interest rate, we have time period, we can easily calculate A. We have, for a salvage value is a future value, right? So F, we know the value is $4,000, interest rate, E period, same thing, we can calculate the annuity. Add them all together, that's 94.6. So the annuity is 94.6. Not a big number, right? But the concept is the same for alternative B. For alternative B, what we do is that we have same thing. We have the same annual cost and annual revenue. We keep them here, don't need to do anything to them. We convert our initial cost, initial investment to annuity. We convert the future salvage value to annuity as well. Then we do the calculation and it gives us $2,524.08. 8 cents, right? After doing all this conversion and calculation, we can see alternative B definitely provides more value than alternative A. So we're going to choose B, right? Okay, that's question 8. Here's question 9. The cash flow for a particular investment is given below. The MARR equals to 15%. MARR equals to 15%. What is the present worth of the investment? What is the present worth of the investment? So take a few minutes to calculate this. Then we can work on it together. All right. So this part, easy, right? We have we need to convert present worth, so we don't need to do anything. This is already here, right? The this part, relatively easy. This is the annuity for each year. We just need to convert annuity to present value. That function we have used so many times. We know our MARR, we know the period, straightforward. This part pretty easy as well. This part a bit tricky. We don't deal with this that much. It's basically a gradient cash flow, right? So here's exactly how I calculate. Like I said, this part don't need to do anything. This part we convert future value to present value. For the $4,000. Remember we said, right, if we want to use the gradient cash flow, one important thing to remember is that the cash flow need to have 0 value on year 1. Need to have the 0 value on year 1, and then each year is increase or decrease by a constant amount of money, right? So here's the problem. It does increase or decrease by the same amount of a constant. It's basically decrease $1,000 per year, but on year 1 it's not 0. So to deal with this is basically we take out a negative 7,000 annuity out of this gradient cash flow, right? So basically what we have is annuity for 4 years. Each year the cost is $7,000, and then we have another gradient cash flow. For year 1 it's 0 cost. For year 2 is $1,000 cost, right? 8,000 minus 7,000, $1,000 cost. For year 3, 9,000 minus 7,000, $3,000 cost. Year 4, 10,000 minus 7,000, $3,000 cost, right? So if that's the case, basically what we have is one annuity, the cash flow is negative $7,000. And because we already have a cash flow is positive $14,000, we add this two together. That's our annuity. And based on the annuity, we can calculate the present value, right? Based on the annuity, we can calculate the present value. Then we have once the constant, the gradient is negative $1,000, and that gives us another gradient cash flow. So we can do the calculation as well. Add or do the calculation on each part, add them all together. Then we find out the present value is negative $3,514. That's our annuity. Right. That, if you understand what I said, it's pretty it's pretty standard. Basically what we want to do is just to put this gradient cash flow, break it down to one annuity, and the other is a gradient cash flow. We can apply this function, right? The only reason we are doing it because for this function to work, we need to have the first year's cash flow cost equal to 0, the cash flow equal to 0. But if that is a bit challenging, you can always just convert each year's annual cost using A, calculate P, right? Using A, calculate P. Or this is more like using F, calculate P. Using F, calculate P, right? For future cash flow, for each year, just convert this negative 7,000 in year 1, what is P? Negative 8,000 for year 2, what is P? So on and so forth, right? With those calculations, you can find the result.